Rolling?
Mm-hmm.
Okay. So today we'll be controlling the robot using two cases. One is using only encoders and the second is using only the IMU. Now as you can see here, there is an outline of the path that the robot has to follow. This is kind of small for the amount of distance that the robot is traveling because of clearance between. If you consider this as an obstacle, there is a bit of a clearance between all of them. So the hope is now that it starts here, it will go equally to here, here, here and here while executing 90 degrees right turns at every turn of the rectangle and navigate the rectangle correctly, navigate around the obstacle correctly. So now we will first run the script which uses only the encoder data to actually make the turns. So yeah, here it goes. Thank you. I will take my comments. I will make my comments about the accuracy of encoders and IMUs and how both of them differ after the robot has already done both the tests, because you will also be able to see how the accuracy differs. So this is the first test for the robot navigation, and this uses only encoders. So now we are playing it. So as you can see, it does do the 90-degree turns somewhat accurately, but due to small inaccuracies, they actually start building up over time. And where the robot is supposed to face this way, it actually faces this way. So these inaccuracies start building up over this angle, and this angle, leading to overall inaccuracy of a few degrees, which is great. And if you see the plot that it draws of the robot, okay, no, sorry, not wrong plot. Yeah, but if you see the plot that it draws in the robot, in the submission, you can see that it's off by a few degrees and a few centimeters. So now we will set this back up and we will run it using the IMU. So this is the test 2 with the IMU and the encoder both integrated. So my encoder has a bit of a bias, so it does calibrate it as the code starts. Now as you can see, it's a much more careful turn and a much more tighter tolerance for angles as the robot is moving, and it actually moves very close to 90 degrees. And the reason it moves slower is because it's actually checking at every turn to see if the angle value is correct. And you can see now it's actually facing in the right direction. It actually made all 4 turns pretty accurately. And if you see the plot that it drew right here, you can see that there's just a small bit of deviation in every angle, which I'm trying to remove. But for all intents and purposes of the course, the obstacle course that the robot needs to navigate through, not the entire course, it is uh, it is pretty accurate as compared to the encoders, which just go everywhere. Although I did try to calibrate and tune the encoders as much as I could, so it's actually very close to 90 degrees even with the encoders. So as for comments, the IMU plots are very reliable, and the IMU sensor is also very reliable after calibrating and after removing the bias, while the encoders will need much more fine tuning and much more calibration and calculations to actually execute turns. So the encoder is great for keeping it straight. As you saw in both the tests, the robot always moved straight. It did not deviate, even though my wheels are a bit wonky after so many tests. So it did keep the robot straight, and it did turn pretty close, but I still think that the encoder needs to be used only for the straight movement, and the IMU needs to be used only for the angles. The IMU can also be used to calculate the heading and to calculate the distance it has traveled. So it can do the job of the encoder, but I chose not to use it because of the bias that it already has, and it would add up to a lot of calculations, making the code a bit slower. So yeah, that's it. Thank you so much.